So here, problem 1 asks us to solve the following systems of equations using substitution. So substitution is going to entail isolating one variable in one of the equations in our system and plugging that value into the other equation to find the value of one of our variables. So here, we're going to isolate our y variable to get y is equal to 1 minus x. We're then going to plug this value of y into our second equation, y is equal to x squared minus 1, to get 1 minus x is equal to x squared minus 1. We can do some rearranging here, like add 1 to both sides to get 2 minus x is equal to x squared. And then we can get all of our x variables onto one side of the equation so that we can have 0 on the other side. So that's going to get us to x squared plus x minus 2 is equal to 0. And then from there we can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So we're going to have x is going to be equal to negative b, which is 1, plus or minus the square root of 1 squared minus 4 times 1 times negative 2 over 2 times 1. So then from there we can simplify a bit, plug some values into our calculator to get x is equal to negative 1 plus or minus the square root of 9 over 2. And of course the square root of 9 is 3, so that's going to be equal to negative 1 plus or minus 3 over 2. So we can solve this by hand. So negative 1 plus 3 over 2. Negative 1 plus 3 is 2, divided by 2 is 1. So x is going to be equal to 1. And x is also going to be equal to negative 1 minus 3 over 2, which is going to get us negative 2. So if you plug these values back into our first equation up here, the y is equal to 1 minus x. So we're going to have when x is equal to 1, y is equal to 1 minus x, 1 minus 1, y is equal to 0. And when x is equal to negative 2, y is equal to 1 minus negative 2, y is equal to 3. So our solution here is 1 comma 0 and negative 2 comma 3. So that's for part A. Part B is going to operate very similarly. So we already have our y isolated on this side. We have y is equal to 2x minus 3. So we can plug in our 2x minus 3 into the y here in the second equation. 2x minus 3 squared minus 1 is equal to 4x. So when we FOIL this out, the 2x minus 3, and square that, it's going to get us 4x squared minus 12x plus 9 minus 1 is equal to 4x. So if we subtract out our 4x over here and simplify it to get 0 on the side, so we do minus 4x minus 4x, we're going to have 4x squared minus 16x plus 8 is equal to 0. Here we can simplify a little bit. We can factor out the 4 to get 4 times x squared minus 4x plus 2 is equal to 0. And then from here, again, on this part of our equation, we can use the quadratic formula. So x is going to go to negative b. B is a negative 4, so 4 plus or minus the square root of negative 4 squared minus 4ac over 2a, right? So then here, again, once we simplify everything, plug it into our calculators, we're going to have x is equal to 4 plus or minus rad 8 over 2. That can be simplified, of course, into 2 plus or minus rad 2. Because 8 is equal to 4 times 2, we can square root the 4 to get 2 over here, then divide by 2. And then when we plug 2 plus or minus rad 2 into our calculators, we get x is equal to 3.41 and 0.59. So then again, we take our x values of 3.41 and 0.59 and plug it in again up here into our y is equal to 2x minus 3. So when x is equal to 3.41, y is equal to 2x minus 3, which gives us 3.82 when we plug it into our calculator. When x is equal to 0.59, y is equal to 2, 0.59 minus 3, which gives us negative 1.82. So our solution here is going to be the ordered pairs 3.41, comma 3.82, and 0.59, negative 1.82. And that's it for problem 1. That's how you solve these two systems of equations using substitution and the quadratic formula.